Any questions?
One question to start off with. You've been talking about prosthetics and whatnot a bit earlier.
Yeah.
This idea seems to be, it's been floating around for 150 years ago. How come we're not at the stage where we are like Darth Vader and this stuff is still pretty clunky, and is it like hardware or economics or?
It's both, hardware and economics. So for example, if you want to have like the most advanced prosthesis that exists, hellishly expensive. I mean, if you want to actually ask someone who needs a prosthesis what they want, they basically want 2 actions from the hand that lets them make a cup of tea. That's for British people anyway. And anything beyond that is kind of over-engineered, but people kind of focus on the over-engineering a lot. But the real issue is control. None of the methods that are currently being used for control are good enough to control the best prosthesis that exists, because either you need a lot of surgery, put in a lot of different things to interface with all the neurons, or you're picking up much lower quality signals, and control is the issue. That's the reason it's my main focus, really, and in my research interest is because control is the biggest issue.
Does anyone? Yeah.
I've got one observation first of all, which is that maybe early famous cyborgs might have been users of the iron lung, in fact. But I do have a question which is related to, you were saying how difficult it was to interpret the EEG data.
Yeah.
What kind of techniques are you using? It feels like it's the sort of thing that would lend itself to hill climbing techniques, the sort of thing that UCL's got a bit of a name for these days.
Usually you kind of do a power spectrum thing where you kind of turn it into each frequency and you look at the amplitude of each frequency and all this kind of thing. But the main issue with something like EEG is just the noise is way too high. So in all those samples I showed you, the problem was noise, and you can't really get your signal out of those noise unless you know exactly what's causing it. And another big issue that EEG has for designing a control system is if I'm wearing the cap and I train and I've fully got control of the system, I take the cap off, the next day I put it on, it's not in the exact same place, the signals are completely different. And so it's these kind of things which you can't really do a fancy algorithm to get around. You're still going to have the issues. There are a lot of people working on improving the algorithms to try and get the best thing, but it's more of a physical issue than an algorithm issue. Or at least that's what I think. Yeah?
Very good talk. How does the UK compare to other countries in terms of developments in this area?
We're pretty good, but we fall behind America on the basis of DARPA, which is the American Defense America Research something thing. They get an absolute fortune every year to spend, and they have pumped so much money into this area every single year for at least a decade, and we can't match that level of funding. So for the amount of funding that goes in compared to the research that comes out, we're probably ahead of them. But for the amount of money we can put into it, we're never, it's kind of impossible to keep up with them. The main reason being that it's the biggest funder in this area is military, because the kind of philosophy that the Americans have is, a soldier costs however many $100,000 to train. If they've got a limb blown off and you can replace it for less, then that's a good economic choice. And so they pump in all this money so that in places like Afghanistan and Iraq, where IEDs are the main issue, you can just replace the limbs and put a soldier back into active duty for much less than it would cost. And so they've pumped tens of millions a year into this area. So that puts us behind them. Yeah. Yeah.
What kind of technology do you think will be popularly used for people who are not disabled in the future?
Not disabled. So proper augmentations, sort of thing, as are in the sci-fi. It's a good question. It depends what we can make, really, and what the regulations are. Because as it currently exists, to be able to sell a technology like this for that purpose, to get it CE marked or something, it's quite hard, it's quite expensive, and if you said, oh, I want to design this device to, enhance someone who's already fine, you might not get this. You probably not get the CE marking because they're like, well, that's not really a good use of it. But I mean, things already exist and already out there that people can have. The two common ones is an RF chip implanted into the hand that lets you control things, like sign into your computer, sign into your phone. And the coolest one that I like is a little magnet in the end of your finger, embedded in silicon. And that lets you feel fluctuations in magnetic fields. The most common thing that you kind of might come across is it lets you kind of tell if a hard drive is spinning or not because of the EM from the motor. And then the thing that they do to show it off is people with that can lift up a paper clip on the tip of their finger. I think it will be something like the kind of control aspect where you can kind of control your technology by thinking about it, or interfacing things like phones, which everyone carries with them all the time and may as well be part of them, actually being part of them. So in some science fiction, in things like Almost Human, you have people who have the screen is underlaid their skin, so you can't see it, but when it turns on, they just look at their hand and their screen is in their hand. And other things where you've got a keyboard is in your arm, but it's not there until you kind of want to use it, and then it appears and you can just press the buttons. I mean, we're getting close to that kind of thing. There's a very good bit of research that came out recently with people where you have a detector on a kind of wristwatch, and you have a RF generator ring on your index finger, and you can tell anywhere between here and here where you're touching. So you could use that as like a keyboard. If you drew onto your arm a keyboard, you could actually pick out exactly where you're touching. So I think it's that kind of thing is what we're interfacing into, and as things like augmented reality take over, those kind of things being integrated more into, say contact lenses, which would require an insane amount of minimization technology and really quite a lot of advancement, but so that you have an overlay on your kind of world giving you information and you can interact with it just by touching the body. I think that's where it's going to go for augmentation. I also think that'll be in about 30 years' time. But there's a good thing that says anything that scientists say will be in more than 20 years' time will always be in more than 20 years' time in the future. So, yeah. Any other question? Yeah?
Again, so you mentioned AR, but I mean, we've got augmented reality with glasses and visible.
Yeah.
Do you think that's going to have an impact on some kind of field? That feels like it.
Yes, I think it will. But I mean, at the moment, they're quite clunky. Google Glass failed because it was ugly. People didn't want to wear it, and it also was in a small area of the field. I think that technology will very much kind of come in and will start to inform the kind of control system stuff we use to do it. I think that's how it will happen first. You'll wear an augmented reality thing, and you will control it by touching your own skin, and then as that miniaturizes, you kind of get a whole integrated system. We use VR in our lab quite a lot. So one of the kind of things we work on is neuropathic pain. Especially if you've lost a limb, your brain is no longer receiving the signals from your arm correctly. So you have this kind of pain network that builds up because your brain doesn't know what's going on. What you find is by putting someone in an augmented reality scenario and they move their arm and you've got something picking up their arm movements and it shows their eyes then picking up the object and moving it, you break this pain circuit and the neuropathic pain is lost for a period of time from minutes to hours to weeks depending on the patient. So VR very much can be integrated in, VR and AR very much can be integrated into kind of rehabilitation as well as augmentation.